All right. Thanks everyone for joining. This is what, the fourth or fifth webinar, maybe even sixth. This one's going to be covering. It's going to be a little more informal today. This is going to be covering kind of a getting started with CycleCloud. We'll look a little bit at just creating clusters, cluster templates, what some of the different cluster types look like, and then basically open it up for a Q&A. We really, we've gotten some feedback from some teams that they don't really know where to get started, don't know what VM types to start with, and so figured this would be useful. I will ask that if you're not speaking, if you go ahead and mute yourself, just to cut down on any background noise. All right, so at this point, you all, I think, have been able to log into your CycleCloud installs. If you haven't been able to, please let us know via Google Group. We definitely help figure out what's going on there. When you log in for the first time, you'll see a screen that looks a little bit like this. Actually, it'll probably prompt you to change your password first, but then you'll see this. This is the cluster creation screen. Yours will look a little bit different. This is kind of my own personal test install. So I have a lot of different custom clusters as well as some legacy clusters that we've deprecated. But for the most part, the things that you're mainly going to be interested in are the schedulers up here at the top. And then probably maybe even the single VM type. I know a few of you have been looking at the BGFS file systems. So those are in NFS filers. Those are kind of the main things that you guys will probably be dealing with. It is possible to create your own completely custom cluster. We're not going to get into that today, but the docs do cover some of that. So if, let's say, at my institution, we're used to using Slurm. I'm not picking this by any, there's no favoritism here. This just happens to be the one that I work with the most. So let's call this SCC test 1. So the next thing, after you give it a name, there are some links in here to both the Slurm documentation and then also the GitHub repo where we have all of the, basically all the chef recipes and cluster templates that we use. If you come down to required settings, you do have to pick the region. You guys are all pinned to South Central US, so you won't be able to deploy anything outside of that. Currently, yeah, I'll go and leave it at that for now. The master or scheduler VM type, this is for a vanilla cluster. This is essentially the combination of a login node, a scheduler, and a small NFS server. And we'll talk a little bit later on how you can make that disk on this node a little bit bigger, because right now it's fairly small. And this is, I think, the point at which a lot of people get really tripped up because there's a lot of information on this page. If you look, I can see every single VM type that's available to my subscription. In fact, if I uncheck this, I can see every single VM type that's available on Azure, which is not very helpful. Usually, if you don't know what you're looking for, I'd recommend clicking on this compute type filter. There are, we have categorized these basically the same categorization that we do on the Azure Docs site. So for the purposes of the competition, you're really probably going to be interested in these first three. So high performance compute, compute optimized, and GPU. The biggest difference between these, the HPC options, these are really CPU only InfiniBand instances. They're either optimized for memory bandwidth or CPU plus InfiniBand. The compute optimized SKUs, this is the F series. This is another popular choice because the cost per hour is a little bit cheaper, but these don't have InfiniBand. So high clock speeds, decent memory ratio, but no InfiniBand. And then finally, GPU instances. Before we get into the Q&A, and I know this question is going to come up, there is an ongoing escalation internally to get the quota unblocked for the subscription. So I hope to have more news on that later today. I'll send that out via the Google group. Eventually, you should have access to most of these SKUs. Again, if there's anything in particular that a team is wanting, please feel free to reach out to me directly. A little bit on the naming convention. I can't remember if we touched on this on the other webinar. If you look after, we have NC here that stands for NVIDIA Compute, and then a number. That number is indicating how many cores the machine has. But then you see some of these that have like an R after them or an RS. Those kind of indicate some of the extra functionality that's enabled on those SKUs. So if you see an S, those are eligible for either premium or ultra SSDs. So they're kind of storage optimized SKUs. And then if you see an R after them, those do support InfiniBand. Note that the anything earlier than NC24 v3 and the H16R, those have an older version of our InfiniBand stack, and so those don't support IP over IB. They only support an older version of Intel MPI. So you can still use those, especially if you go back and look at the H16s in particular. These have a lot of memory per core. It comes out to about 13 or 14 gigs per core. But I would recommend probably not using the InfiniBand enabled. On this screen, when you're picking your resources, you can also see what the cost per hour is. This is really important, and this does start to add up even for a single VM. Some of you have found this out the hard way. You can also see the cost per core. This is a really common thing for people to optimize for. You know, the HC44 has a much higher clock speed, is a much more CPU heavy VM type, but it also costs almost twice as much as, actually more than twice as much as the HB120 per core. Even though the cost for the VM is about the same. So these are important things to look at. You also have your, you know, the quota that you have and the quota that's available. Again, this is shared, but the goal is that the total quota available to the subscription is going to be high enough that no team can really monopolize any VM type, especially not for the whole duration of the competition. So let's go ahead. I think we spent enough time on machine types. We'll go ahead and pick HC44. Oh, I don't want to do that for my head node. Let's cancel this and come back. Right, settings, I want to do that for my HPC VM type. Now, we'll look in a minute at the differences between these different schedulers and kind of how they work with CycleCloud. If you notice in Slurm, our default template has, you have your scheduler or master VM, and then you have an HPC VM type and an HTC VM type. Really, the difference between these is that this HPC VM type has a special flag set on it that any multi-node jobs created with that are in this partition are going to be placed on the same InfiniBand fabric or in the same VM scale set. This is really important if you want to be able to use InfiniBand. If you don't put it in a single placement group, you could have nodes that end up on different InfiniBand fabrics. We also have a high throughput VM type here, which is for, you know, your more serial jobs, embarrassingly parallel jobs that you don't need InfiniBand, but you still want to be able to submit, you know, those types of jobs on the same cluster. So the FV2 is a common VM type here, as is E and D series VMs. Moving down to the auto scaling section. So this is kind of the bread and butter of CycleCloud. This is why part of the reason why we encourage you guys to use this feature, because this helps you control your cost. So what I can do here is for both HPC and HTC, let's say that I want to be able to start only 2 nodes of the HPC VM type, but I want to be able to start, let's say, 1,000 cores of the HTC VM type. This max VMs per scale set, don't worry about this, just leave it at 100. This only really impacts the HPC VM type, and you guys aren't going to be running at a scale that this matters. You can use low priority for the HTC execute hosts by default. We'll take a look when we look at the cluster template at how you can enable that for the HPC nodes as well. And then the last thing that's required is picking a VNet. Now you guys only have one subnet in your resource group that you're allowed to deploy in, so this is a pretty easy choice for you. For the most part, this advanced settings section, you probably won't be changing very much. You can choose a different image here if you don't like CentOS, you'd rather use Ubuntu, we do support that. Or if you want to use a custom image from the marketplace. I am currently looking at an issue with marketplace images. I think it's related to the roles you guys have, so I hope to have that resolved this week as well. Cluster init we'll touch on in just a minute. We'll skip that for now. And then the advanced networking sections, I would just leave these alone. Definitely don't need public execute nodes. Cloud init, so there is a pending update to CycleCloud that's going to be pushed out to your installs later today. The version you're on right now, 8.01, version of CentOS 7 that's in there does not support Cloud Init properly. So once I push out that update, I know a few teams have reported having issues testing and using Cloud Init. That should unblock that. So at this point, we're ready to save this, and what would start is a pretty vanilla Slurm cluster. Just hit start here, select OK, and we're deploying things. So I'm going to use some TV magic here and jump over to a cluster that's already been spun up. So this is pretty similar to the one we just looked at, except I've got 4 nodes defined. And one thing you'll notice if you're testing with different schedulers, when you launch a Slurm cluster, you're going to see these nodes show up. Don't be alarmed; they aren't running; they are off, and you can see that if you just hover over the status bar. Essentially, the way Slurm's auto scaling works is we have to predefine all of these nodes, so that Slurm can actually, when a job comes in, Slurm requests what nodes to power on by name. This is a little bit different than if you deploy a PBS cluster. You notice this cluster, it looks like I only have the one node. If I come over to the arrays tab and look at the HP120, I can see that I can actually, well, this wouldn't even start one, but I can start 100 cores of this. Those won't show up in this nodes list until I actually submit jobs, or if I come down and manually add nodes. That's another good point to make. This actions dropdown for adding nodes, this works fine for PBS, Grid Engine, LSF. If you have a license for LSF, HD Condor, all of those will work with this add nodes button. Slurm does not work with that because of the same reasons that I mentioned earlier. Slurm has to kind of know about all of these nodes. You'll end up with nodes coming up that don't actually work. So notice here, this will tell you that you can't add it. I think if I try, oh, okay. Does actually prevent me from doing it. So just be aware, if you do want to start any of these manually, you can do that. You have to click on the node array here, and then you select which nodes you want to start. You can hold down Shift to select multiple, click Actions, and Start. And it'll go ahead and start those up. So pretty straightforward. If I come over here to my terminal, so I've gotten requests from a few people to ask if you can get access to the quote unquote CycleCloud backend. The way that you get access to the backend is via the CycleCloud CLI. You can install the CLI on your own machines or even on your head node. If you click on this help button here in the top right, it'll take you to this about page, and you can actually click on the download CLI tools there. We have binaries for both Windows, Linux, and should work on Mac too. It's just a Python utility. So install that. You'll then have this CycleCloud command. If you install it as root, it'll go and use your local bin. You can install it to your own user account as well. If you type CycleCloud with no options, you'll see all these arguments that you can give to it. The first thing you're going to want to do is a CycleCloud initialize. This is where you actually point it to your CycleCloud install, give it your username and password so that it can actually connect back to that. And at this point, you can, if you want to, you can actually interact with CycleCloud completely from the command line. So if I do a CycleCloud show cluster, Slurm demo, then we see that these are all of the nodes that are defined in the cluster. The nice thing too is that once you have if you have your SSH key on this box as well, where you have the CLI installed, you can do a CycleCloud connect master Slurm demo. And this will actually log me in directly to that cluster. You can get that command as well if you click on the node and then click on connect. You'll have both the SSH command line to use for that, but then also the CycleCloud connect command. One thing, and this is called out here, you want to make sure that before you start your cluster, and actually you can add it after you start the cluster, but before you try and log in, you have to go to your user profile, click on edit, and add an SSH public key. Otherwise, you won't have any way to log into the cluster. I mentioned this on the other webinar, but I'll reiterate it here. There is a way in CycleCloud to add a password login to your clusters. I highly, highly recommend that you don't do that and just use SSH keys. Passwords are very insecure when you have public IPs attached to your clusters. The Azure IP space is a constant, attack vector. So just try not to use passwords. That includes don't log into the master node and enable password logins and assign a password that way. Just stay away from, stick with SSH keys. Every year, we end up with somebody getting hacked. So at least during the testing period. So these nodes, these are still coming up. So now I have my Slurm cluster here, and this is basically like any other Slurm cluster that you would see on-prem. So if I want to submit a job, let's get some of those HTC nodes going. So let's do an SBatch. I just want a single node. And we'll just tell it to sleep for a little while. So now if I do an sinfo again, you see that I've got my, each one of my, oops, got to tell it to use the partition. So now I've an HTC node and an HPC node coming up. The HPC node was already coming up, but that's okay. If we come back here and take a look, sure enough, we've got one node that's in the acquiring state. In the same page, you can see your cost per hour. This is per cluster. This is not for all of your clusters. That's why I have the plugin in the URL that you can query to get your cost across all of your clusters. But this is useful, especially while you're just testing things out. Just keep an eye on what this cost per hour is, because that'll give you a good idea if you're spending a lot. This usage down here also shows you how much you've spent in the last 24 hours, and you can mouse over that to see over the last 7 and 30 days too. So again, if you're trying to figure out where is all of this cost coming from, this is a good page to look at. If there are any errors starting nodes, I know a few of you have already seen this before. This issues section will change into a link, a little show button that you can click on, and it'll give you more detail about the error. Whether it was an error provisioning stuff from Azure, whether it was an error with installing the software. Once you get into cluster init and cloud init, sometimes you'll hit issues with that. So it's a good starting place to look at. And definitely if you're hitting errors, please include that information in your message to the Google group. If I want a copy of this cluster, this is another common thing, especially while I'm testing and doing A/B testing. I can just click on the cluster here and click on this duplicate button. And it'll actually, give me a chance to rename it and change any settings that I want to change. But just an easy way to stamp out clones of the cluster that I already have. So I'm going to pause there. Again, this is just kind of the basics of CycleCloud, and see if there are any questions. You can either put them in chat or ask them. SKUs we see are available to our subscription in our region. Yes, that's correct. So this is when you go to this edit page and you're choosing your VM type, by default, this hide unavailable is checked. So we'll only show you what's available in your region and in your subscription, and that'll also show you the quota. Now note that it is possible if there's no quota available, or if there's no free nodes available, you can see in this list that you might still see a quota of some number, but available would be 0. So you have to check about both of those, or check on both of those. But yes, by default, it should be at least filtered down to what's available to the subscription as a whole.
Well, have you guys had a chance to look at some of the larger HPC nodes to figure out why we're having trouble with the quota on those and availability?
Yep, yeah, that's a great point. Thanks, Mary. So I've sort of mentioned this, but I think it's buried in so many threads now going about that. There's both the per family quota, which is what you see here. This is the quota for each of the VM types that's controlled for your account. So you notice that like my E16 v3 quota is way higher than any of my other EV4 or whatever. There's an additional quota that's not really easily exposed via CycleCloud. and that's the total regional quota. By default, new subscriptions have a default or total regional quota of only 350 cores. And so that's the quota that you guys are actually running into right now with the HPC series. That's the piece that I mentioned earlier in the call. I'm working to escalate that. I hope to have that unblocked today.
Thanks.
So yeah, I know that's a pain point. It's a constant struggle. So, but for the competition itself, that regional vCPU quota is an aggregate. Once it's increased, it's more or less an aggregate of like all the quota that we've requested increases for. So we shouldn't run into that for the competition at all. Great question. Mike Smith is asking about increasing the NFS size of the cluster. Yeah, we'll get to that in just a minute. I just wanted to pause for general CycleCloud questions for kind of the basics of using the UI. Differences between Slurm, PBS, and Torque. Honestly, this is what I say. I don't really play favorites, and this is why we support all of the schedulers that we do, and we even work with other schedulers and custom schedulers to get that support for customers. It's really down to customer preference. For the most part, these are all at feature parity inside of CycleCloud with a few minor differences that you guys shouldn't hit because they really only apply to really large scale clusters. But yeah, I mean, it's really just whatever you're familiar with. I think PBS and Torque behave similarly, and so you might start with some of those. There's a lot of information out there, but a lot of institutions are also moving to Slurm today. There are wrappers. We do install the wrapper scripts on the Slurm clusters as well. So if you're not used to like sinfo and sq, but you're used to maybe doing a qstat and seeing it in that format, we do have those wrappers on there too. So if you want to try out Slurm, but some of the team members may be more familiar with a different scheduler, you can go that route. Is InfiniBand enabled by default? When we deploy our cluster, it says IB device not found. Let's follow up on the Google group because that depends on the VM or the OS type that you picked, the VM type that you picked, and a few other minor things. But it should be enabled by default if you picked an InfiniBand capable SKU. Can we get to the back end of the panel to install Azure template for Grafana or Lustre? So you don't need, I mentioned this earlier on the call, you don't need to be able to log into the CycleCloud VM itself. If you go to this, click on this question mark up here, click on download CLI tools, you will get the installer for the CycleCloud CLI. That's all you need to import the templates, and we'll go through importing a custom template here in a minute. All right, let's go ahead and, in the interest of time, we'll go ahead and move on to custom templates. Now, I know a few of you have asked about Slurm in particular. There is, and I'll post this to the Google group too. You do have to, if you want a working Slurm template to start from, you do have to pick this specific 2.1.1 template. The master branch is currently pending a new release to be pulled into CycleCloud for the next release. So I'll put this link in chat, but this is essentially the template that I've come here and just grabbed this. You can click on raw and copy and paste it if you want. But if I come over to Visual Studio here, I've already made some changes in here, but for the most part, this is just starting from that template that we saw in GitHub. The template format is pretty straightforward. It is documented in our docs site, but sometimes finding the relevant pieces you want to customize can be a little bit tricky. This is hierarchical. So we have our Slurm cluster that's defined. You can actually define multiple clusters inside of a single template file. The default, though, is just a 1-to-1 ratio. A lot of this stuff you probably don't really want to mess with, especially anything with the $sign in front of it. These are parameters that are usually exposed via the UI. So you can easily break your clusters if you start messing with those and you don't know what you're doing. To add NFS, and I'll provide this full template via the Google group as well, just for an example. It's pretty much the same thing for PBS. Actually, it is the same thing for PBS or Grid Engine or any other cluster type. So you can see we've got a defaults node section. This section applies to all of the nodes in the cluster. So your master node, all of the node arrays, etc. And then we get into specific node configuration. So this is where, probably you want a different machine type, sometimes a different image for your master node than you would from your execute nodes. Similarly, you probably want different software sometimes installed on the master node that you don't want installed elsewhere. The main change here is adding in some definitions for attaching a different volume. So here I'm saying I want to attach a 200 gig volume. I do want it to be persistent. So if I shut down the cluster and start it back up, this volume, all the data on the volume is still there. I'm going to use a standard SSD, and then I'm going to mount it at a mount point I define called data. And that's what this next section is. So we've got cyclecloud.mounts.data. This name is referenced by this mount point. So I'm saying I want to mount this at /data, and if it's not already formatted or hasn't already been formatted by CycleCloud, go ahead and format that. This FS type is optional. I think we'll default to either XFS or ext4 if you don't specify it. And then we define the actual NFS export. So if we just did these two pieces, we would mount the 200 gig volume at /data, and it's only available on this one node. If we want to, though, we can do this as an NFS mount at the /data export path. So that's all we need to create the NFS share from the scheduler node, but now we need to get it mounted on the compute nodes. So we come down a little bit further. One thing you might notice is that the scheduler master node is defined as a node. That's a single VM type in Azure. And then we have node arrays, which are behind the scenes. By default, these are VM scale sets. And so anytime you're deploying a bunch of the same types of nodes, any sort of homogeneous deployment, VM scale sets are typically the best way to do that. And so again, we can see that we've got a different machine type, different image name, etc. In the configuration section, this is a little bit specific to Slurm, but you can see whether or not Slurm is even going to attempt to auto-scale this node array. It is possible to disable that and then manually add and remove nodes. This is just telling Slurm that if I don't specify a partition, saw this when I submitted the job, it just defaults to this one particular node array. In our implementation, a node array always maps to a partition in Slurm. So to simplify things, you can think of it that way. And then the slurm.hpc equals true. This is what I was talking about earlier around, is this going to be packed onto the same InfiniBand fabric as much as possible, or is it going to essentially not care when a job requests multiple nodes? And then here we can see the change that we need to make to actually mount this different NFS filer. So all we need is give the mount a name. This name doesn't really matter. It just can't be the same if you have multiple mounts defined in this same section. We tell it this is an NFS type. The mount point, I want you to mount it at /data, and its export name on the NFS server is /data. And similarly down here, we have node array HTC. Now, the most common question we get around the Slurm clusters is, okay, great, I have my HPC VM type, I have my high throughput VM type, now I want a GPU node. How do I do that? And the common misconception is, well, since there's only 2 node arrays here, and when I go to the UI, I only see 2 of them, then I can only have 2 different node types. That's not true at all. We can come in here and say, node array, we'll call it GPU for simplicity's sake. One cool thing, if the only difference between this VM, this node array and the other node array is the machine type, then you can actually do extends equals HPC. And what this does is, if I left it just like this, imported my cluster, I would get a GPU node array that has exactly the same parameters as this HPC node array. So the machine type, VM type, etc. But then I can start to override different attributes. So like if I want to say machine type equals standard 24, just picking a random one. If you do specify the names in here, be very careful about the way that you name it. If you go back to the CycleCloud UI, you can actually see these names so that you don't have to try and guess at them. So these are, if you select one in here, you'll see this name. This is the name that you need to copy and paste for the machine type. But let's say that you want to get a little bit fancier and you want to be able to select this VM type when you come in here to create the cluster. You can actually, that's where this parameters section comes in. So we put this at the end of the file because you don't really need to do this if you're customizing cluster templates and everything like that. But if you want to be able to change these on the fly later, then you probably want to come in here and add a new section. We can come down here and look for machine type. Okay, so here we've got the different machine types. What I can do is just copy one of these sections, this last section for HTC VM type, HTC machine type, and just change this label to be GPU machine type. And then, yeah, this parameter type is what helps filter that selection so that when you click on this, you don't have to type in a plain text value or anything. It'll take you to that machine type selector. And then up here for my node array, I can just change this to be GPU machine type. Go ahead and save that. So now I have a text template defined. How do I turn this into a cluster? So I'm going to open up my terminal here just for simplicity's sake. I can see I've got my slurmfiler.txt. And if I do CycleCloud, just to make sure, oops. Okay, so I can see my clusters, everything's initialized. So now what I want to do is import this template. And I want to import this as a template, not as a cluster, because I want to be able to create multiples of these from the UI. So I'll do a CycleCloud import template. You can also do import cluster -t. It's the same command, but we just give you an easier way to do it. And I'll call this my Slurm template -f for the file name. And then since I don't have a cluster inside of this template file that's called my Slurm template, I do have to do a -c Slurm to tell it import the Slurm cluster from this text file. That. And now if we pop back over to my, create a new one, we can see that I've got my Slurm template here. I can come in, and now I see I have a GPU VM type. Unfortunately, from this view, you won't see the NFS mount points or anything, but they are still there. In fact, we can, if we go ahead and just save this cluster, and I come in here and click on Show Detail for the master node, come over here to Node, I can actually see in the volume section here, just to verify that, yes, I have a data volume, it's 200 gigs, it's going to be a standard SSD. Any questions about cluster templates? I know I kind of ran through that quickly.
Quick question, where do we find some of these cluster templates?
Great question. So the first place to start, if you go to the CycleCloud documentation, we are using CycleCloud version 8. It's a preview release, but documentation here is going to be more relevant to CycleCloud 8. And you come down to this how to and customize clusters and use cluster templates. There's actually a link here that'll take you to the query that you can use on GitHub to find all of our default templates. You can also just go to GitHub and search for CycleCloud, and you'll get basically the Slurm PBS Pro. We've got some other project types in here. Just be aware that some of these that you pick may not work, right? For instance, I know this LAMPS cluster has not been updated for a while. It shouldn't even show up on your installs. So stick with the main scheduler templates unless you have specific questions. But for PBS Pro, for the most part, it's pretty straightforward. If you just search for CycleCloud, you can even search for CycleCloud-PBS Pro. It'll take you right to it. One thing to note too, should be standard on all of our clusters, but just want to point it out. If you notice that you're starting your cluster and you're not getting the scheduler installed, and you haven't tried to upload a custom version of the scheduler project, which unless you really know what you're doing, I would avoid doing, because it's really easy to break our auto scaling if you're changing settings in there. If you look at these cluster init lines, anything that has a CycleCloud / prefix is telling CycleCloud use the built-in version of the project. It is possible to start customizing this, and we have customers who do it, but it's definitely a more advanced topic. One other thing that has come up too, sometimes you have a running cluster. Let's take my Slurm demo cluster, for example, and I want to be able to make a change to this via my cluster template. Well, if I go and change the template and then I re-import it as a template, it's not going to apply to this cluster. But you definitely need to be careful if you're going to import the template as a cluster, because all of those parameters in there actually need to have values. So one thing that you'll probably want to do is export the parameters of your running cluster. So you can do this with CycleCloud export parameters and then Slurm demo. And I'm going to run this without redirecting first so you can see what this does. Really, this just prints out the JSON pairs, key value pairs for all of my cluster parameters that I've defined. This is a really useful way to get this parameters file if you're wanting to work mostly from the CLI. Once you have this defined, you can actually redirect it to usually do something like that. Now, if we wanted to update this cluster to basically work with our new template, what we can do is if I come over here and open up this JSON file, remember we added that GPU node array. So we have to add that parameter type, or add that the parameter definition in here. So I'm just going to add a new section, GPU machine type. So now that I have this, if I wanted to import this as a cluster, I can do a CycleCloud. Instead of an import template, we'll do import cluster. And instead of my Slurm template, we'll do Slurm demo. Same file name, because we want to use that same template. And then after this, I've specified the Slurm cluster, but now I need to add -- force, because we already have. If we do this without the force, you're going to get an error saying this already exists. Oh, I'm missing one key thing, and I almost broke my cluster. We now have to specify that parameters file. So this will be the Slurm demo.json. Now -- force. If I imported this without the -p, as at least one team has already found out, you'll actually end up with null records for some of the important things in your cluster, and that can definitely break things. So now if I come back over here and take a look, now you'll notice this is particular to Slurm because we've defined these nodes. We basically created these nodes via a script that runs on the Slurm head node. This is only something that you will need to do for Slurm. If I go to the arrays tab, I see that I have my GPU, HPC, and HTC arrays, but I don't have any of those showing up here. And this is going to be a problem when Slurm starts to try and start stuff up. What I actually have to do on a Slurm cluster is come over to my head node. And this is documented in the docs. If you go to the docs page, you come down to the reference section under schedulers. We talk about customizing a Slurm cluster. There's a script that you have to come in here and run. And this will actually tell Slurm to recreate the node definitions. So I'll come in here, CycleCloud Slurm.sh, scale. So you can see now it's going to go ahead and it's complaining because I set default partition on both the HPC and HTC. That's okay for now. We'll just ignore that. And if I come back here now, oops, window.
Yeah. Huh? Who's that?
Hey guys, if you're off mute, can you go on mute? So now we can see that we do have a GPU node array defined. It's got 48 cores. So that's kind of the basics there. Again, that's something you'll only have to do about for Slurm clusters. You don't have to do anything special for PBS or Grid Engine or anything.
So
right.
when you do that, is it fine to have nodes running? Will it just work around that, or does everything need to shut down first?
Yeah, and so in some cases it's okay to do that. If you're adding new nodes, or like adding a new partition, or if you're increasing the size of a partition, it's safe to do that with the running nodes. And if you notice here, my one node that was running is still running. If you're making changes to any changes for a Slurm cluster, and this again is only Slurm because of the static definition. If I come in here and change, for instance, the VM type, or even more important, if I change the image or any of the configuration settings for a partition, you actually need to run, and this is in the docs too, you need to do a CycleCloud slurm.sh remove _nodes. And this is actually going to go through and delete those definitions. You'll note that it's complaining here at the end about this one node that's still running, but that's fine. And then when you run the scale command, it'll completely recreate them. If you don't do the remove nodes first, especially if you have a node running, you will end up with this partition still going to be kind of broken. So you'll want to make sure to go ahead and shut this down. You can shut these down directly from the UI here as well. You usually want to go ahead and terminate them. Good question, though. It's the intended way to install additional software. So there's two main ways. If you're installing something like an OS package, then you'll probably want to use either Cloud Init, which is in here. You can specify either an actual Cloud Init configuration, or you can even just add a bin bash and then install -y tmux or whatever. So this will apply if I want this to run on all of them. I can put it in here, or there in the docs we show how you can embed this in your cluster template too, so you can include it in the node default section. The other way to do it is through CycleCloud projects. I don't think we're going to have time to run through all of that today, but there is a I'm just going to search for it. Use projects. Okay, and so essentially, if you remember when we were looking at this cluster template, there's these cluster init lines. And these are collections of chef recipes and or Python and shell scripts that get ran when the node first comes up. And so going back to this docs page, essentially you can do from the CLI a CycleCloud project init. In fact, let's just do this really quickly. Cloud project init my project. Default locker for all of you will be Azure-storage. And then if I cd into this my project directory, you can see that we've got this directory tree here. Blobs, for the most part, you can probably ignore. Those are defined in the projects file. That's basically for any large blob storage that you don't want. But then you have in this spec section, we've got a default spec, and then we've got, most of you probably want to stick with this cluster init section. It's the easiest to work with. What we can do is inside of cluster init scripts, specs default scripts. So this is a directory that will automatically run in alphanumerical order any scripts that you put in here. So this. And so now if I want to include this as part of my cluster, I can do a CycleCloud project upload. And then if I come back to the cluster itself and go to advanced settings, and let's say I want this to run on the master node, so I can click on this browse button. And I've now got this my project. So I double click on my project, select which version of my project, and click select the actual spec too, and then click save. And now that's included in my project and in my cluster. And you can also do that from the template. The same thing would apply if we wanted to add this to everything. For example, you can just copy this line. This is where the CycleCloud prefix matters for your project. You probably just want to do or you do want to do without the CycleCloud there, and you also need to add the version number. So those are kind of the two ways to do things. If you're installing stuff that can be installed to like a shared directory, typically we just have, we'll only install things to an NFS server just to keep things simpler. That way you don't have to try and script some of those installs because they can be kind of tricky. Tried to spin up a new Slurm cluster just now, but got an issue saying error configuring software. So this is where you'll want to click on that show info command or show info button and get what the specific error is that it's having installing software. I'm guessing it's probably related to the Quota issues, but we can follow up offline. And great point. You can actually log into the node, especially when it's gotten to that point. You can use your SSH key pair and the CycleCloud user to actually log in and see what's going on there. We try to access the ClusterNet browse button. Okay, I'll have to look into the permissions for the ClusterNet browse. For now, you should be able to add it to your to a cluster template, but I can probably resolve that pretty quickly today. It's just you don't have permission to browse that storage account. Thanks for pointing that out. Any other questions? Just going back to make sure I didn't miss any.
It sounds like you've covered everything and the questions are slowing down. I did see a question that might be relevant in the Google group that came from Mary about using SPAC. Yeah, certainly I think it's okay to use SPAC.
Yeah, I don't think I must have missed that one. Sorry, Mary.
Yeah,
you can definitely use SPAC, and I would probably either invoke it via ClusterInit or CloudInit, like I mentioned before. Oh, one thing that I should mention when we're talking about CloudInit. CloudInit runs before anything else on the VM. And so if you put things in here, note that CycleCloud could revert some of those changes if you're trying to change things like the scheduler configuration. So if you have anything that needs to run after CycleCloud's done the configuration, you should use a ClusterInit project.
So the order is CloudInit and then CycleCloud stuff and then ClusterInit?
Yes, correct. So Jacob, yeah, as I mentioned earlier in the call, I'm still working on the quota thing. I hope to have it resolved today. Ooh, keep alive. That is a great point. Okay, so keep alive in the cluster UI will only work for PBS and grid engine clusters. If you come in here and try and edit these nodes for a Slurm cluster, you'll note that there is, I guess it doesn't apply here. If you try and add a node here, it's a little clearer, but basically keep alive via the UI does not work for Slurm. And so if you look in the Slurm documentation or the CycleCloud documentation for Slurm, there is actually detailed information here on actually disabling auto scaling for either specific nodes or entire partitions in your cluster. You actually have to make those change to slurm.conf and then restart slurm-ctld. There's no way currently for us to propagate that value via the UI. Good question though. For PBS Pro and Grid Engine, that should work as expected through the UI. Just be careful with keep alive and make sure you remember to turn it back off or shut your VMs down later. It's a good way to rack up the charges. All right, take the silence as no other questions. If you guys do have any other questions that come up or errors that you're running into, definitely ping the Google group. We'll try and follow up as quickly as we can. All right, thanks everybody. Thanks for joining. Hope this was helpful.
Thanks, Andy.
Thanks a lot.